in the second phase, only that happens with mostly the server actually sends some kind of the certificate to the client. So this certificate is X.509 compatible certificate. There is a standard how that certificate should look like, what all information the certificate should have. One of the fundamental thing that should have is the public key. The public key of the server is going to be part of the this certificate. So that is there, and bunch of other components are there. We will see in a minute. So that certificate, it not necessarily be a single certificate, but a bunch of them actually leading to the something called the certifying authority. So normally when a certificate is given as input, what you can do is the client is here. You tell I am giving you a server is actually sending a certificate to the client. If you want to validate this certificate, you can actually go to maybe one more server, let's call that as P1. And from P1 identity can be verified whether P1 is a genuine certifier of the certificate of the server or not, I don't know. So maybe I can go to P2. So and then finally after some of the cases you finally hit a phase, hit the server called as certifying authority. So either the certificate supplied by the client is directly identifying a certifying agency, or it is identifying a bunch of intermediate servers through which you can actually go and reach the certifying agency, which can actually finally validate that certificate. It is in simple terms what it means is, let's say I am telling something to you, and I am saying that what I am saying is truthful or not. If you want to verify that, you can go to person X and verify that. If person X says, okay, this is correct, and then now you can ask the question whether person X is indeed truthful or not. Okay, now X says, if you want me to be verified, then you can go to person Y. And the person Y, so you can ask this question, whether X is truthful or not, whether Y is truthful or not, or so how long you can continue. So at one point you hit a dead end, which is called as certifying agency. He is the last person. So assuming the last person is known to everybody and he always tells the truth, you can actually trace back, and then if I that since I actually went back, I can go up to the certifying agency, the last person in the chain. So I can since the immediate next person in the certifying agency can also be trusted. So since he is saying this person is truthful, the other person 2 steps beyond can also be trusted, and back forth till the server can also be trusted. So that is how it actually works. But in most of the cases, the intermediate chains are not used, particularly in the HTTP conversation. The certificate directly identify the certifying agencies. And then there is an optional value called the DP-element value that is also sent as part of this communication. And the second optional value, the server can also request for a certificate from the client if it is there. So otherwise also it's okay. And then finally server says this phase is done. So I sent the certificate, now my job is done. So once the certificate is received by the server, the client actually need to check the validity of that certificate. So whether what server is saying is indeed correct or it's not correct. This validation or verification process is done through these many things. So it can check something called the revocation list. So whenever a certificate is issued, so let's say hypothetically I got a certificate. So this is simply, you can think of it as a file, and it has got the public key information. So that is PU, and it comes with some kind of the expiry date. Let's say 23/12/2021. So this certificate is valid till this date. And what client need to do is, for some reason, either because the server has changed its public key, or something else has happened. By virtue of that, this certificate, although has got a validity till 23rd December 2021, but it has been invalidated. The certifying agency says, so I did issue this certificate, its validity is up to this date, but I am keeping a list of a list called as the revocation list. So this is saying that so and so certificate issued to so and so server is actually invalidated. So what client can do is, it can go and check who is the certifying agency and what it has got published in the revocation list, whether the certificate that the server is supplying is been invalidated by the certifying agency or not. That is the meaning of this revocation list. So it is carrying some validity date, but before the expiry of the validity date, the certificate has been revoked, either because of the server has changed the public key or for some other management reasons or non-technical reasons, whatever it is. So simple thing is, so this certificate is still valid. It has not been invalidated by the certifying agency. And then the certifying agency's credibility itself is also verified, meaning whether that certifying agency that the server identifies, okay, my certificate is certified by so and so certification authority, is it a credible source? And then finally the public key that is supplied as part of the certificate. So the server supplied certificate itself looks something like that. It has got these many components. So it has got the public key of the server. This is our PU, and then it has got a serial number. So let's say 1, 2, 3, 4, 5 is the serial number. So this is the serial number given by the certifying agency. And then the validity I say 23rd 12 2021 the date. Till then this certificate is valid. And what is the domain? So maybe it is xyz.com. So that this certificate is issued to xyz.com domain or google.com domain or any other iita.ac.in domain. And then the component is the issuer domain, the certifying agency's domain. This might be popularly used one, might be VeriSign things. So what is the domain of that certifying agency? So that is indicated here. And at the end of this, all this data is taken and then a digital signature is created using the private key of the certifying agency and then signature at the end of this certificate. So when the client needs to verify, it can pick up what is the issuer's domain. If it is saying verisign.com, so the client, usually the web browsers have got a list of the certifying agency, the popularly used ones, and then these are kind of hard coded on the web browsers. So it can pick up, okay, this certificate is saying it is certified by VeriSign. Basically what I'm saying is, VeriSign's public key is part of that list that the browser keeps. It can take that and then take up this portion. It can verify this encrypted and this is basically the hash which is encrypted using the private key of the certifying agency. You can take that and then decrypt it and then recalculate the hash on this data and then check whether everything is fine. So if this is validated, then the client thinks that, okay, whatever the server has supplied as a certificate is actually indeed valid, particularly the date, revocation list, and then you take the public key of the certifying agency and decrypt the signature, encrypted signature that comes along with the server supplied certificate, and then recalculate the hash on the remaining part of the certificate elements and then compare what you decrypted with that. If these two match, then you say that your verification is successful. So that is how the client actually verifies that. We are here in this hierarchy. So certificate is supplied by the server now to the client. So once that is done, the next phase, the phase 3 begins, where the key exchange and the certificate, the server and the client actually decide on a bunch of parameters, which algorithm to use for encryption and the which key to be used for encryption. That happens in the phase 3. So that is basically the client encrypts a secret that is sent by the server and then send it. So the idea is the following. So if the client says this is my public key to the server, the server sends one random number, that is the secret, and then you encrypt this and send it to the other guy using your private key. So using the other pair of the key, using the public key, if the other entity can actually decrypt that, then this message indeed has come from the other source. That is the meaning of our interpretation of this message. And they actually exchange the keys. The key itself is delivered using the key exchange method. Is it TP-Hellman key exchange or other key exchange protocols that are there in the chute? Using one of that method, this key, or which key, the session key is actually exchanged, and then optionally the client can also send us its own certificate to the server. And once that is done in the phase 3, in the last phase, the phase 4, the crypto algorithms and the key exchange mechanisms are all agreed now. And the only thing that is left out is, okay, everything is good. Now I am done. So this a finished message is sent. So the specification, I am going to use the block cipher and using the triple DES, using this key, using this key exchange method, we are going to exchange the data. All that is set in the specification, and then finally say we are done. Finished message is sent. So from the client side to the server, finished is done, and in the next message that the server sends, it echoes back a similar thing. So okay, so and so cryptographic algorithms are set now, and I am also done with this thing. So it is all finished. So the 4 pages are now completed. So that is how the SSL connection or handshake protocol actually works. So using this handshake protocol, basically you just say hello to each other and then identify using which sort of which protocol algorithms you can actually encrypt the data and exchange the session keys, and how you actually derive the session key and other parameters, and then you begin the conversation with that. So using this 4 pages, the connection is established. So an interesting thing to note is this SSL handshake happens after the TCP 3-way handshake, meaning if the client is here and the server is here, the client sends a sync message to the server, and sends as usual sync plus the acknowledgement, and the third message and acknowledgement goes back from the client to the server. And after this 3-way handshake, is done, this is where the SSL handshake begins along the timeline. So basically first you establish TCP connection, and then once the TCP connection is established between the client and the server, you start the SSL handshake protocol. So whole sequence is the application asks, I want to talk using the encrypted or SSL protocol, and then the SSL itself in turn invokes the TCP to establish a connection between the 2 parties, and then to initiate its own handshake protocol, communication between the client and server, and the set of cryptographic parameters or suit is negotiated, all set, and then finally the data transmission happens. So its data transmission is below this along the timeline once the handshake is done. So that is about the SSL protocol. Basically, the record protocol is used for carrying the data, and these three protocols, the alert and the handshake protocol, and then the change cipher suit protocol, is actually used for management of the communication between the two parties. So that brings us to the end of the discussion on the SSL. So let's go and look into how TLS works. TLS is a short form for Transport Layer Security. The way to understand Transport Layer Security is, with respect to SSL, what are the changes? Why we are understanding only the changes? Because SSL started as an implementation to provide security to the conversation that is happening between the two systems, and the implementation was already there. And subsequently, over the years, the IETF took this protocol as a means and then came up with a standardization. So this TLS is basically an SSL taken and then standardized as a internet standard document in an RFC. So this is actually an IETF standard. The major difference between the SSL stopped at the version number 3. So if you look at the record protocol that I was talking to, so it has got this major and minor version. So the major version of SSL was set to 3 and the minor version was set to 0. In the TLS, both of them are actually set to number 3. So it's particularly the first version of the TLS. Subsequently, there are minor changes in that one. And then it introduced a change in the MAC calculation, which goes something like this. In the previous case of the SSL, there are a couple of keys that are used. Remember, MAC requires a key. That key is concatenated with a couple of pads that are generated. Instead of concatenating the message, whatever you want to transmit is here. The application data is here, and then you take a secret key, and that key is concatenated with these two kinds of the pads. So what TLS did is, instead of concatenating the thought of XORing the key with this pad, and then the second pad with the same key, and then you finally concatenate that with the message, and all these quantities taken together, you pass it into the hash generation algorithm, and that is actually becomes the MAC. That is one major difference. And for a period of time, this SSL actually right from the beginning, it actually used the security, but TLS made a slight change. The initial conversation that was happening between the client and the server is done using the plain text protocol, and finally it actually switches to the encrypted version. And another major difference is, otherwise the structure and all, the whatever the record protocol was there, the same record protocol that was there in the SSL is also there in the TLS. There is absolutely no change other than the version number. TLS is not backward compatible, meaning if you decide to use TLS, if the other one of the client or the server is actually operating the SSL, the other one operating the TLS, they cannot converge. So if you have an implementation of the TLS, then any client which wants to use SSL, you cannot talk to the kind of client using this security mechanism. And it introduces several more kind of the alert messages. The message that error message or the fatal error message that we are referring to. In addition to what SSL defines, in addition to that, the TLS defines few more message types. So particularly with the changed encryption and the new algorithm that were brought in. So that is the fundamental difference. Otherwise, other than being the internet standard document, which actually makes everybody who is implementing the TLS mandatory to take those many algorithms or support those many algorithms. Other than that, there is no major difference between the SSL and the TLS version. And it also adds couple of more cryptographic algorithms, and it probably takes one algorithm which was there in the SSL, it does not support. So that background, basically SSL and TLS provides the tunnel, the encrypted terminal between the two communication endpoints. So any applications can use this. So HTTP is one such application. So that is a popular application. It uses the SSL or the TLS for communication. If you use the SSL for communication, so all the data that is given by the HTTP is encrypted, including what all is encrypted, the URL that is sent. So when I type xyz.com, if that is operating the sent over the SSL communication, then that URL is also encrypted. The actual content of that document, whatever I browse, let's say I go to the Microsoft.com website and some content, whatever is there in the website is browsed. That content, whatever is coming from the server to my browser, is also encrypted. If you have something data, maybe I am filling a form in my computer, which is present in the browser. If I, let's say, username and password and click on that, that content is also encrypted and sent to the other field. The HTTP protocol itself, there is something called as the HTTP header. That header is also encrypted using the SSL connection, and the cookies that are used between the client and server is also encrypted. So this cookie is different from the cookie that is used at the TCP. These cookies are meant to, if let's say I visit a website, the server sometimes to know with whom the server is engaging the conversation. Next time I visit, the server might push some content which is the personalized content to my web browser. So in order to identify the end users, the cookies are used. These are HTTP cookies. Those are also encrypted and sent to the when they are exchanging. So basically the server keeps that in the client browser. So next time the same user establishes a connection with the same server, that cookie is actually identified at the server, and then it, okay, this is the cookie, then this is the set of things that I want to identify. This is the kind of user that I'm talking to. It actually identifies that. So that is how it can happen. So basically, if you see that HTTP is here, and it is giving a bunch of documents. So those are encrypted using the TLS conversation. Beneath that, you have got the TCP, and then you got the IP protocol and possibly an Ethernet protocol here, and the same thing other around. At the peer end, these are all reversed. So when I am saying establishing the connection, so TLS component here is establishing the connection with the TLS here, and then the HTTP protocol data is taken, then it is understood at the other end. So rest all is actually the same thing. So that is how this HTTP is one of the popular applications, the most widely used application which actually operates over the SSL or the TLS. So in this case, if you use the SSL connection, the HTTP clients also act as the TLS or the SSL client. Basically, the browser is the one which is actually initiating. Remember, in the SSL, that 4 pages before that, the server and the client are saying hello. The client is the one which actually initiating or beginning the conversation. The first hello is sent from the client. So that hello is going from the computer, which is actually the HTTP client as well. So the HTTP client is also acting as the TLS or the SSL client. So, as I said, before any HTTP request is sent from the client to the server. So, how does the conversation happen is the HTTP level. So, I want so and so resources to be sent. So, these are, you can call the resources or sometimes called as the object. Get so and so component xyz.com. So, whatever is the index file that is there in the xyz.com domain might be the one which is actually pulled. So that this request, I get that index.html file is an HTTP request. So before this request goes, the TLS connection need to be established. So TLS connection is established. Before that, the TCP connection need to be established. So as I said again, the first thing is TCP connection. Second thing is the TLS connection, and then subsequently along the timeline you got the HTTP request being made. The client is sending request to the server. So this is how the entire conversation look like. So you got maybe I can add this TCP connection here. And then the TLS connection, this is the number one along the timeline, first one. Second one is the TLS conversation, and then you exchange the data. The client might send as many number of the HTTP requests as required, more than one HTTP request in the same TLS connection. And once you are done with the exchange, every encrypted HTTP request goes to the server, and then the server sends back an encrypted response. So once the bunch of things these are repeated, then finally the connection can be closed. The closure can be either initiated by the client or it can be initiated by the server. Either one of them ask to close the connection. Then the TLS connection is closed, and subsequently the TCP connection is also closed. So that is the one application of the SSL, that popularly used application. Let's end the discussion on the SSL or HTTP by looking at the security aspects of the SSL protocol itself. So if you can recollect, the discussion is, I said that the TLS connection is established using the subsequently the TCP's three-way handshake, and the TLS connection begins at this space, the client and the server. So since the TLS itself is not in the picture when the client is basically established a connection with the server, nothing prevents from a malicious client from sending an attack, mounting an attack which is called as the SYN flood attack. So it is basically sending a bunch of SYN messages one after the other. This we discussed earlier. So for each one of them, the server is actually sending. We have not entered the TLS handshake phase at all, this phase. So if the client is malicious, it can very well mount a SYN flood attack, send a bunch of SYN messages to the client. TLS is still not there in the picture, and the server keeps responding back thinking that these are genuine requests, and then at one point of time it might run out of the resources. Basically, it might run out of the memory available itself, or the number of the connection pools which are active at this point can surge, and then it may not be able to process new connection possible. Even if I use SSL or TLS, you can very well mount a SYN flood attack on the server and take down that. So that is how in today's is also denial of service attacks are still very much popular. The another kind of the attack that people found out is the attacker may not be interested in mounting the SYN flood attack, but what he can do is, his goal is to, if you mount the SYN flood attack, what is the resource that you are targeting? It is the memory that get depleted. There is a limited amount of memory that is allocated to this server, which is dedicated for servicing the HTTP request. If it runs out of that, then it is not able to take it. So what the if it is operating over SSL, what can happen is remember, the TLS connection requires the client and server to do a bunch of computations by exchanging the random numbers and deriving the session key and so forth. This phase itself is quite computationally expensive. So what the attacker can do is, he can establish a genuine TCP connection, and then he might repeatedly ask to change the cipher suit that is used in the conversation. Maybe one cipher suit at this phase of time, again he says, no, I don't want to use one set of protocol, I am using the second set of algorithms and the third set, and again I am switching back to the first set of algorithm and so forth. This repeated switching and deriving the session key itself, in each time you switch the protocol itself, is quite a bit of work to do. And particularly if the client has no intentions to do or engage in a meaningful conversation with the server, it can keep doing this. So basically each time the client makes a request, the server keeps on switching, and then both of them engage in deriving new set of session keys and switching to a new set of algorithms. So by repeatedly doing it, server might run out of or run busy, or lot of CPU power itself is utilized at the server. So particularly if you have a bunch of clients, all of them are malicious. If each one of them are simultaneously doing similar kind of exercise by asking the server to repeatedly switch to a new set of the algorithms, then that might burden the server and it might collapse. So that is a new kind of denial of service that brings exclusively by the use of the SSL or the TLS protocol. And so similarly, the client may not ask for the change in the algorithms, but it might ask simply to change the key that is used for the encrypting the data. So if that also happens, then also the server might be burdened with a lot of computation, and then at one point of time it might collapse. So that's how the attacks, the operation of the SSL itself can be leveraged to generate new set of the denial of service attacks. To summarize, SSL or the TLS protocol establishes a tunnel between two communication endpoints. This is application agnostic. You can use any application layer protocol at the top and then transmit the data with the confidentiality, integrity set, and in addition to that, it can also provide you the authentication. There are a bunch of protocols defined, particularly the record protocol, and 3 of the management protocols are also defined for this conversation to happen. So the first phase is the TCP connection, and then in the second phase you actually do the TLS handshake, and subsequently to that you actually transfer the application data. So this is the sequence in which the data itself is encrypted and transferred. So that brings us to the end of this lecture on the SSL and the TLS.